Hello everyone. Welcome back to Gigasitron. Both displays are designed for embedded system projects, and they can be used with the Arduino IDE together with Giga's XC-GUI library. The main purpose of this demo is to show how easy it is to use different LCD sizes with the same software structure. I will first connect the 1.47-inch TFT LCD module and run a simple graphics demo. At the same moment, I will directly swap it with a 2-inch TFT LCD module. Once the system is reset, the software will detect the connected LCD automatically and initialize the correct display settings. So instead of changing the code every time we use a different LCD, the same program can support multiple displays. This makes development faster and easier to maintain. Now, let's go through the wiring, Arduino IDE SEP, XC-GUI configuration, and a live graphics demo. Let's visit Gigasitron.com for more product details. The manuals, specifications, and supporting documents are all available on the website. This should provide a good overview of the LCD modules. Next, we will move to the Arduino IDE and install the XC-GUI library using the Library Manager. The development board used in this demo is the Raspberry Pi Pico 2W. From the Arduino Library Manager, search for XC-GUI. After the library appears, you can install it directly. Additional documentation and source code are available on its GitHub page. The XC-GUI comes with two tools: Image Converter and Font Converter. I will show you how to create custom image and font resources for XC-GUI. The required XC-GUI tools are available from the Gigasitron GitHub repository and can be used free of charge. Please note that these tools should only be used with fonts and images that you have the right to use. Do not use copyrighted, patented, or unlicensed materials. Any use of such content is at your own risk. For font resources, Google Fonts is a good recommended option. The XC-GUI image converter is simple and straightforward. After importing an image, you can crop and adjust it before generating the output file. The tool supports both RLE compressed and uncompressed image formats. Since most microcontrollers have limited flash memory, RLE compression is recommended to reduce storage usage. After adjusting the IDE, click Generate and enter your preferred output file name. The converter will generate an XC-GUI compatible file for Arduino IDE projects. Place the generated file in the same folder as the Arduino sketch file so it can be included and compiled correctly. After the file is generated, you can open it and rename it later if you want. I hope that is clear. Now, let's move on to the font converter. The process is almost the same as the image converter. First, please prepare your font file in TEF format. For this demo, I will download a font from Google Fonts. Some people use Windows system fonts, but I do not recommend that unless you have checked the license, because the usage may be restricted. Great! Now, let's import the font into the font converter and generate the output file. The process is almost the same as the image converter. After generating it, place the font file in the same folder as your Arduino IDE sketch. Please change your preferred font size. Same as previous. After the file is generated, you can open it and change the font name if you want. Great! Now let's move on to the real demo. I have already wired the Raspberry Pi Pico 2W to the XC-1.47A LCD module. This LCD has a resolution of 172 by 320 pixels. I hope you have installed XC-GUI following the steps shown earlier. Now, Let's open one of its examples for the ST7789 display driver. As you can see here, lines 6 to 15 are used to define the GPIO connections. For the Raspberry Pi Pico board, please follow this wiring. Before uploading the code, please make sure you have selected the correct board. In this demo, I am using the Raspberry Pi Pico 2W, so I will select Raspberry Pi Pico 2W and set the upload method to UF2. Okay? Now let's compile the program and wait for the process to complete. Great! The code has compiled successfully. Now I will put the Pico 2W into flashing mode. To do that, I will hold the bootsil button and then plug in the USB cable. We should see the UF2 drive appear shortly. Now, let's upload the program to the board and check the result. Something went wrong. But don't worry, it looks like the IDE did not detect the UF2 drive automatically. We can click the Raspberry Pi Pico board selection at the top. Then choose UF2 as the port. Once it is selected, we should see UF2 connected at the bottom right corner of the Arduino IDE. Now, let's try to upload the code again. I'll hold the LCD up to the camera so that once it works, we can see the result clearly. Bingo! It works! The Gigasitron splash screen is showing on the LCD, and the running number is updating correctly. Now, I will swap the display to the Gigasitron 2-inch LCD without uploading the code again. They are same driver but different sizes. Let's try it. The pinout is matched pin to pin, so I can directly swap the LCD without rewiring anything. Okay, the swap is done. Now I'll reset the board and let's check the result. Bingo! It works again, and the display is detected correctly. Thank you for watching. If you find this demo useful, please support us by buying our LCD modules from Gigasitron.